In a previous video, we have demonstrated how Phoscript can simplify various programming languages by being a metaprogramming script, mapping reverse Polish notation tokens or words to functions of the host programming language. In this video, we shall show you how Phoscript can be a metaprogramming script to the bash shell itself, with examples mapping for ffmpeg commands, which have notoriously complicated parameters but very sophisticated functionalities for creating and editing audio and video files. We call this extension to bash shell Phoshell, spelled Phoshell. In fact, this video itself is prepared using Phoshell with Phoscript words or tokens mapping to ffmpeg commands. The task performed by Phoshell invoked using the command /sm, where sm stands for stack machine, consists of the following steps. First, get duration of audio file. Second, create silent MP4 from PNG file set to the length of the audio file. 3. Merge audio file and video file. 4. Re-encode MP4 to remove inconsistent parameters. Let us briefly look at the code of SM, the main file for Phoshell, to examine its mechanisms. As shown on the screen, Phoshell basically consists of a split push execute loop, where the command line string is split into tokens or words in Phof or Phoscript terminology. Each of the word or token is tested to see if it is a function word. If true, it will be evaluated or executed. Otherwise, it is simply a data word. Then it will be pushed onto the data stack. As you can see on the screen, the code to split the command line string into tokens or words is shown at line 189. Line 190 defines the global data stack as a bash array. Line 193 marks the start of the test push execute loop. We shall look at the definition of is function at line 199 later. Line 200 tests if the current token or word is a function. Line 203 executes it by calling eval. We have added additional tests for aliases and special operators such as addition, which is marked by a plus sign. Finally, at line 215, the non-function token or word is pushed onto the data stack. Before we go on further, we would like to show you the link to our GitHub page so that you may be able to download the code and notes for reference. You should be able to find the link on the YouTube page for this video or navigate through github.com/udexon udexon/mi4. Once you get to the page shown on the screen, you will be able to find the link to the source code of Phoshell command sm by scrolling further down to see it. Our first example will be a simple addition operation, as shown on the screen. The commands to type are /sm 55 space 22 space plus space f_s, then press enter. The results shown are 1: space 77, where 1 is the number of items on the stack and 77 is the result of 55 plus 22. As we have seen previously, the push or execute loop in the file sm will push the numbers 55 and 22 onto the data stack S at line 223. Note that the line number may have changed as we have added some functions above. At line 218, when the loop encounters a plus sign, it executes the command add : which is shown at line 168. In line 170, function f_n is called, which reads the top item on the stack and store its value in variable num1. Then function f_pop pops the top item. num2 is assigned its value similarly. In line 173, the values of the two numbers are added and stored in variable num. Finally, at line 176, the value of num is pushed onto the stack. Then, function f_s, which displays all items on the stack, is defined at line 24. It consists of a loop which iterates over each element in the array S and prints it. Next, we shall demonstrate the flexibility of Phoshell with an example of calling ffmpeg commands and simplifying their lengthy and complex parameters. The simplest task in making a presentation video consists of the following. Step 1. Create a slide. Make a screenshot. Convert the screenshot into a video clip with voiceover. Step 2. Record the audio using mobile phone or other devices. Step 3. Merge the audio and video stream into one MP4 file. And finally, step 4. Re-encode the MP4 to the resolution required to eliminate inconsistency created in the previous steps. As you can see, the complexity of the ffmpeg parameters involved would turn off the most seasoned programmers. With Phoshell, we have turned the above to something like the following. First, get audio duration and make MP4 from PNG. The commands involved are .sm input file, f_duration, duplicate, PNG file, output MP4 file, and f_p to m, which stands for PNG to MP4. Step 3. Merge the audio and video stream into one MP4 file. The commands are /sm input audio file, input MP4 file, output MP4 file, f_mav, where MAV stands for merge audio video. As you can see, we can choose the command which is easy to remember. And finally, re-encode the MP4 file to the resolution required. And the command is /sm input file, output file, f_renc. Phoshell simplifies both bash and ffmpeg commands and parameters via the following mechanisms. First, hiding details. Second, renaming or alias of functions with something easier to remember. This can be done arbitrarily according to the choice of programmers, as well as using native language or national language with Unicode. That is, more than one aliases can point to the same function. To illustrate, for the step to obtain the duration of the audio file, the original command is shown on the screen, which we shall not read out, as it is too complicated. And the corresponding Phoscript command is ./sm input file f_duration. The Phoscript function f underscore duration is defined as following, which help us achieve the objective of hiding details. Further, f underscore duration can be aliased as dur : using the command alias dur : equals to f underscore duration. Finally, we can actually connect the f duration command and f underscore p to m, which is the command to convert a PNG file to MP4 in one command line. In this particular step 1, that is to get the audio duration and make an MP4 from PNG, we demonstrate the classic stack machine mechanism of storing the input of the first function onto the stack and then used by the second function. In this case, t.m4a is the input audio file, and f underscore duration is the function to determine the duration of the input audio. As you can see on the screen, function f underscore duration is defined at line 129. At line 131, A reads the top of stack, which is the input file, and then in line 133 is the full command and parameters of ffprop, which is part of ffmpeg, to determine the duration of the input audio file. Now, as you can see, it is quite complicated because it involves some of the single quote and double quote acrobatics as usual in Bash. Finally, we evaluate the full command, which is at line 137, by calling eval $b$c, and then the result is pushed onto the stack of the global data stack S, and this is done at line 137. F underscore P to M, or convert the PNG file to MP4, will be the last command we will discuss for this presentation, as the remaining steps are actually similar, and we are sure that the readers can actually go through them, and the code are actually self-explanatory. As you can see here, firstly at line 72, the variable O is actually reading the top of stack, which is the output file, and next we are actually reading the input file, and finally T is to read the duration of the previous which is produced by the previous command, which is f underscore duration. So these three variables O, I, and T are fed into the actual ffmpeg command, which are listed in line 76, 77, and 78. Finally, all these three lines are combined together and evaluated. Note that in this case, we do not actually produce any results to be stored on the stack.